All right, just another quick video talking about how we're going to use SALT when we're doing hypothesis testing problems. So a couple of key things to note is that the SALT tool in here doesn't seem to be functional for one sample mean test. So if we're trying to do a problem that kind of looks like this one right here, where we're dealing with a single mean using the Z distribution, then SALT doesn't seem to have that functionality for some reason or another. But it does have some functionality when it comes to dealing with proportions. So if we click on the button there, what happens is we come to the inferential statistics tab, which is similar to what we saw with the confidence interval one here. And then we just need to select what we're trying to do. So if we take a look, it's got plenty of options that we see. We're going to go through these two right here. So we have a one sample proportion test in this problem that we're taking a look at. So if we go back to the problem that we had when it came to that, we're dealing with a single proportion. We're trying to see whether or not 36% of federal civilian employees have a bachelor degree or higher. So we take a quick look. They've sampled some people, and they found that 32 out of 123 held bachelor's degree or higher. So our hypotheses here are going to be P equals 0.36, because that is the supposed going in. And then we are going to take a look at P being less than 0.36. So we're going to need to know that information as we go ahead and as we do these problems to determine what values we get. So the hypothesis proportion is 0.36. And then we need to know what that alternative is, right? So we're going to set that to less than. We need to know the number of successes and the number of trials. So as we come back here, we take a look. We had 123 trials with 32 successes. So we have 32 successes. We have 123 trials. And then we can run this right here, and it's going to give us the information we have. So it spits out the hypotheses we're testing. We want to make sure those are correct. And then it's going to give me my Z statistic and my P value. So that's going to help us answer these questions as we go down. What's the Z statistic? What's the P value? So really, it's just about reading that output. And then once we have that output, we can make our conclusions based on comparing the P value to our alpha value when we take a look there. Some other things that helps us, right? It'll actually give us that estimate of P hat if we happen to need it. So that's kind of useful for us going forward when it comes to that. And then we have the standard error there. So that's really all we're going to be able to use SALT with when it comes to Module 5, because it doesn't have the one sample Z. When we take a look at all these options here, and I'm just not sure why. So we can do the one sample proportion. So while we're here, what we're going to do is we're going to take a look at Module 6. And so Module 6 is going to deal with confidence intervals as well as hypothesis tests using the T distribution. So when we come down here, we can see, okay, well, we have a situation where we are going to use the T distribution because we have 36 values. It's mound-shaped and symmetric, but we don't know the population standard deviation. All we know is the sample standard deviation, and that's going to be a trigger for us to know that we need to use T as opposed to Z. It tells us we're running a two-tailed test, which is going to set up our hypotheses here. So we want to see whether or not what we found here is significantly different from the population mean of 11.5. So as we go through, we click on Use SALT. And now we're going to deal with the one sample T distribution here. And so this is going to say, hey, what was your sample mean? It was 12. What was your sample standard deviation? It was 2. And then it's going to ask us for what that sample size was, which was 36 values right there. And so the hypothesized mean was 11.5. And since we're running a two-tailed test, that is the not equals to alternative. And then we're able to pull this out pretty easily. It's going to give us the hypotheses here. We want to make sure those are right. And then it's going to give us our T statistic as well as the P value that we want. Those are the key critical pieces we want. So we can answer this as 1.5. When it comes to the t-distribution, there's a couple of things. If we use technology like SALT, we can get an exact p-value. What we're going to see in class is we're going to get a t-table, and when we get the t-table, we're not going to be able to get that level of fidelity. So what we're going to end up seeing is that that value is going to fall somewhere between 0.1 and 0.25, right? Here's what it actually is. Cool thing about SALT is we'll get that exact number. So we just have to identify the range of the p-value, which will then allow us to make the conclusions that we need. So that is how we're going to use this going forward. And remember from module 4, if we wanted to run a confidence interval on this, we could create the confidence interval as we see right here. Lower limit, upper limit, relatively straightforward. So that's it for weeks 5 and 6, and there'll be one more video coming up for module 7.